In 9.3c, let's use a confidence interval to draw conclusions for a two-sided test about a population mean. This works just like it would for proportions. So let's go back to the breaking ice example. And now we have different phantom computer output. This is actually for the 95% confidence interval. And remember what we were looking at, the original hypothesis was this, is that the width of these ice cubes we thought was not equal to 29.5. So from this output, let's see where the confidence interval sits. This is not that hard to read. Here we have the confidence level of 95%. Now, is that true? Let's just confirm it for a second. Remember, when we did the test, we chose an alpha, originally of 5%, which means each of these two tails would have to be equally split up because it was a two-sided test. So this tail and this tail was 0.025, and this was also 0.025 for the actual, where the p-value parts would sit for it. So if we construct a confidence interval at 95%, that technically is the same as getting this inner region. Therefore, this two-sided test that we did when we said alpha was 0.05 is equivalent to actually constructing a confidence interval at 95%. Now, be careful. If they had asked us to construct a confidence interval at 99%, that's not equivalent to this alpha. If it was 99%, this alpha would have to be 0.01 and be split equally amongst here. Okay, let's take a look at this though. Here's our estimate that they have. The estimate, or our point estimate, is 29.48, and then they have plus or minus this value. So this here is the confidence interval written out, and then here it is actually computed to what it would be. So based on this, we could say we're 95% confident that the interval from looking at this value to this value captures the true mean width of plastic ice cubes. Okay, fine. Produce that hour. What conclusion would we make? Well, again, we were talking about at the mean of 29.5. Well, is 29.5 within this interval? It actually does sit within this interval, so does that give us enough evidence to, would we say, reject H sub O, or we can't reject it? Well, because it's in the interval, what we would say is it is plausible for it to be a true mean, so we do not have convincing evidence that the true mean is not 29.5. Basically, we're going to make the exact same conclusion as we did with the hypothesis. Originally, we said we cannot reject H sub O and cannot conclude H sub A. Well, same thing here. Because that value of 29.5 is in the interval, we cannot reject H sub O and accept H sub A. So ultimately, this is the same conclusion we made for the significance test. Keeping in mind, if this was originally a one-sided test, we would not do a confidence interval for it. You would only look at the test. Now, do make note, if for this don't break the ice example, if they hadn't given you this computer output, you could have computed the confidence interval on your own using the sample data. And let's just review that quickly. Where you're going to go to the calculator is you're going to go, remember, to stat and then test. Now, in there, you're going to look for the t-interval. So find the t-interval and select that. You can choose data or statistics. We already have the stats on that, so I'm going to click stats. I'm going to type in the mean that we found in the previous video, which was 29.48. The standard deviation was in that previous video also, in addition to the actual sample size of 50. But you can also look at this new computer output. It's going to show all three of those components right here. So you can take the data from here and you can just type it in here. We're going to be 95% confident, so hit, and when you do that, what you're going to see is the confidence interval will come out right here for you. And it's going to be exactly what you see for this computer output. So this is a good way to come up with the interval on your own. And same thing, we're going to make the exact same conclusion because it is the same interval that we cannot reject H sub O and we cannot conclude H sub A. Now let's wrap it up and just interpret the confidence level. This is a great review question. What does a confidence level of 95% mean? Well, if we take random samples of 50 plastic ice cubes and make 95% confidence intervals for the true mean width of the ice cubes, then about 95% of those intervals will include the true mean width. So don't forget the difference between a confidence level and actually stating the confidence interval.